Hi, my name's Shelton and I'm an Oklahoma 4-H STEMist, and you're watching Wind Power Camp Day 1, Wonderful Wind. You may remember from our weather camp our discussion about wind and how the wind works to help create and form tornadoes. The wind can also be transformed into energy, which you will learn more about later on in this camp. Today, let's cover some wind power basics. When gases, like air, warm up, atoms and molecules move around faster, spreading out, and decreasing the density, allowing it to rise. That is why steam off a pot always goes upwards. Cold air will slow down atoms and bring them closer together, making them more dense, so cold air sinks lower. Since warm air rises, it leaves behind an area of low pressure. Why does this happen, you ask? Well, it's density and diffusion, and it happens all the time. Diffusion is defined as the act of spreading or allowing to spread freely. Density is defined as the degree of compactness of a substance. When warm air rises, cold air moves in, replacing the warm air, creating wind. Winter brings higher temperature gradients, especially with the cold front moving in, which can cause higher wind speeds than normal because the cold air is moving in at a lower temperature and the air is being displaced. Temperature gradient describes the temperature differences between 2 points. A higher temperature gradient has an increased pressure difference between air masses and a higher wind speed. A high pressure zone causes clear skies and sunny days. A low pressure zone has the light warm air and is usually caused with clouds and rain. Have you been to the beach? Was it windy when you went? Have you noticed why the wind changes directions at night? This is because during the day, the sun warms up land faster than it can the sea, creating an air current pushing from the sea to land. The opposite happens at night. Land will lose heat faster than the sea does, so it creates an air current pulling wind out to the sea from land. Now let's try this out and see how it works in today's activity. The materials you will need for this activity is 2 metal pans, one with sand and one with ice cubes or ice packs, a candle, something to light your candle with, and a pot holder. Step 1, you need to make sure that there are no drafts in your area where you will be completing your experiment. If there is a draft, you can take a cardboard box and cut off one side of the cardboard box and place it around your experiment. Step 2 is to pour sand into the pan and then put it in the oven at 300 degrees for 5 to 8 minutes, just enough to make the sand warm. You can do however much sand or however little sand you want. You want to make sure to at least cover the bottom of your pan completely with sand. Step 3, while the sand is heating up, get your candle, and put ice in your other pan. If you don't have ice cubes, you can use an ice pack like I did. Step 4, now that we have our second pan with ice and our pan with warm sand, we can then take our candle and light it. Be careful to do this, you might want parent supervision. Then you will place your candle between the 2 pans like so, and then blow it out and observe which direction the smoke flows towards. When you set the pans side by side, you're creating a mini low pressure zone. The air is flowing from the high pressure zone, your hot sand, to the low pressure zone, your ice cubes, to even out. Now that we've completed that activity, why don't we try to make our smoke from our candle go in the opposite direction? Think about how you could accomplish this. If you said to cool the sand and warm the water, then you're right. Now let's try it. You can do this by taking your pan full of sand and placing it in the freezer for 5 minutes. Take your pan that had your ice cubes in it and put lukewarm water in the pan. Place them side by side again, light your candle and blow it out, and watch and see how the smoke changes directions. Join us tomorrow as we discuss how this wind can power our sailboats. For more information, go to 4h.okstate.edu and don't forget to fill out the Microsoft Forms questions and go to Flipgrid and share with us how your experiment went. Bye, campers!